Join me as I dive deep into the mysteries of the ocean to uncover what really happened to the massive Megalodon. Beneath the surface of our world's oceans, a prehistoric predator once ruled. Larger than any shark known today, more fearsome than any creature in the deep, the Megalodon. This monstrous shark dominated the seas for millions of years, an apex predator like no other. The Megalodon, whose name means giant tooth, lived approximately 23 to 3.6 million years ago during the early Miocene to the Pliocene epoch. At an estimated length of 50 to 60 feet, more than double the size of the great white shark, this creature has captured the imaginations of paleontologists and enthusiasts alike. But how did such a giant evolve, and what allowed it to thrive for millions of years? With jaws measuring over 9 feet wide, the Megalodon had a bite force unmatched by any other sea predator. Its primary prey included whales, dolphins, and other large marine creatures. Its hunting techniques were brutal yet efficient. It attacked from below, crushing bones with a bite that exerted over 40,000 pounds of force. We see a 3D animation of how the Megalodon attacked its prey. The screen transitions to comparisons with modern predators and their bite forces, emphasizing the Megalodon's dominance. Marine biologists say Megalodon's size wasn't the only terrifying aspect. Its sheer power and adaptability to different environments meant it could roam virtually any ocean, hunting massive prey with surgical precision. During its reign, the Megalodon roamed oceans teeming with other prehistoric creatures. Vast stretches of shallow seas were filled with marine life, and the Megalodon was at the top of the food chain. But what did the world look like when this colossal predator ruled? During the Miocene and Pliocene epochs, the oceans teemed with diverse and abundant marine life. The warm and shallow waters provided an ideal environment for ecosystems to thrive, boasting an array of habitats including coral reefs, estuaries, and coastal shelves. These rich environments were home to a plethora of organisms that would capture the fascination of scientists today. Early whales began to evolve during this period, showcasing significant adaptations for life in the ocean, including streamlined bodies and a highly developed echolocation system. These magnificent creatures roamed the waters, competing with other formidable predators in their quest for survival. Giant sea turtles glided gracefully through the Miocene and Pliocene seas, some reaching sizes comparable to small cars. These reptiles were crucial to marine ecosystems, consuming vast quantities of seagrass and maintaining healthy underwater meadows. Their long migrations provided vital links between different marine habitats. With their strong flippers and robust shells, they navigated through a rich mosaic of underwater life, including fruitful kelp forests and diverse fish populations. The combination of these attributes contributed to their success as a keystone species during these epochs. In addition to whales and turtles, other predators dominated the seas. Species such as sharks, which have inhabited the oceans for millions of years, underwent significant evolutionary changes, adapting to feast on the plentiful marine life. Gigantic marine predators, including ancient relatives of today's orcas and great white sharks, prowled the oceans, employing their strength and agility to hunt for fish and marine mammals. This array of life contributed to a complex food web, essential for maintaining ecological balance in the oceans. Scientists study fossil evidence to piece together how these ancient ecosystems functioned and the interactions among these creatures. By examining the transition between the Miocene and Pliocene, researchers gain insights into how climate change and rising sea levels influenced marine biodiversity. The abundance of life during these epochs serves as a poignant reminder of the dynamic and ever-changing nature of our oceans. As we reflect on the prehistoric seas, it becomes clear that the intricate relationships forged among marine species laid the groundwork for modern ocean life. With continued exploration and research, we unveil the mysteries of a vibrant prehistoric past, reminding us of the crucial need to protect and preserve our oceans and their diverse inhabitants today. Most of what we know about the Megalodon comes from its teeth, fossils scattered across the globe. These teeth, sometimes as large as an adult human hand, have given us insight into the shark's size, diet, and hunting habits. But is there more to discover? We see footage of some of the largest megalodon teeth discovered, and scientists explaining how these fossils provide clues to megalodon's ancient existence. Paleontologists are shedding light on the enigmatic lives of ancient sharks, revealing insights through their fascinating teeth. Each tooth serves as a window into the past, providing critical information about the shark's diet, health, and lifestyle. The myriad of sizes, from needle-like to robust and serrated, hints at the diversity of prey the shark consumed, painting a vivid picture of its ecological niche. With every tooth discovered, researchers analyze wear patterns that tell a story of feeding habits and environmental adaptations. A tooth with signs of heavy wear may indicate a diet rich in tough-shelled prey, such as mollusks, while pristine teeth suggest a different approach to feeding. This nuanced examination allows scientists to piece together the dietary puzzle of these ancient apex predators, illustrating their role in prehistoric marine ecosystems. Yet, as much as we learn, significant gaps remain in our understanding of these magnificent creatures. One pressing question is the full extent of their geographical range. Fossil evidence suggests that some species thrived in warm, shallow waters, while others may have roamed deeper, cooler seas. Investigating these habitats reveals how they adapted to a variety of marine environments across ancient oceans. Another enigma is the eventual extinction of certain shark species. While climate changes, oceanic shifts, and the emergence of new competitors likely played roles, the precise reasons behind their decline are still debated. The fossil record gives us fragments of information, but it is not always enough to create a comprehensive picture. To unravel these mysteries, paleontologists employ advanced techniques, such as isotopic analysis. This method allows researchers to infer not only the diet, but also the habitat preferences of these ancient sharks, further enriching our understanding of their evolutionary journey. As we continue to unearth new fossils and refine our methodologies, each discovery propels us closer to understanding the complexities of prehistoric life. The teeth, once considered mere remnants, have become invaluable artifacts that offer profound insights into the behaviors and environments of long-extinct shark species. So what caused the downfall of this giant predator? As Earth's climate began to cool during the Pliocene, the oceans changed, and with them, the food sources that sustained the megalodon. Did competition from other species, such as orcas, contribute to its extinction? Or was it the gradual decline in prey that sealed its fate? We show animations of the changing climate and shrinking food supply, while marine biologists discuss competing theories about megalodon's extinction. The vast oceans that once served as the realm of the megalodon, a formidable predator at the pinnacle of the marine food chain, witnessed profound changes leading to its abrupt disappearance. As temperatures began to cool during the Pliocene epoch, the ecological balance was effectively disrupted, creating a strikingly different underwater environment. The flourishing warm waters that provided the megalodon with ample prey began to shrink, pushing this colossal shark to its limits in a realm where adaptability was paramount. Compounding the climatic shifts were the emergence of newly evolved marine predators. Among these, the killer whale, known for its intelligence and powerful hunting strategies, soon became a rival for resources. The competition for food intensified as these specialized hunters echoed through the deep, adding pressure to an already struggling megalodon. These sociable and versatile predators displayed an ability to cooperate, mend tactics, and employ various strategies for hunting, traits that the solitary megalodon could not easily counteract. The megalodon's apex status was once unchallenged. However, it developed a unique reliance on specific prey that thrived in warmer conditions. As the oceanic temperatures dropped and marine ecosystems shifted, the availability of these prey species dwindled, compelling the megalodon into deeper waters and pushing it farther from efficient hunting zones. The layers of the marine food web realigned, leading to significant changes that would ultimately favor nimble and adaptable species rather than the colossal format of the megalodon. As the last remnants of its reign faded from the seas, echoes of the megalodon's once dominant presence remain alive in the fossil records. The enigmatic nature of its extinction sparks intrigue and debate among scientists and marine enthusiasts alike, who ponder the delicate interplay of environmental shifts and interspecies competition. Did the cooling waters alone spell doom for this gentle giant? Or was it also the rise of cunning predators, like the killer whale that sealed its fate? Whatever the precise cause, the ultimate disappearance of the megalodon serves as a poignant reminder of the ever-changing dynamics within our oceans, hinting that even the mightiest can be brought low by a combination of evolutionary change and environmental challenges. Though extinct, the megalodon lives on in popular culture, captivating audiences through films, books, and television. From Hollywood blockbusters to the imaginations of authors and creators, the idea of a giant shark lurking in the depths continues to thrill. Clips from popular movies about Megalodon and interviews with filmmakers discussing the appeal of the prehistoric shark. Filmmaker: say the Megalodon represents the ultimate sea monster. Its sheer size and power tap into our primal fear of the unknown. That's why it's such an enduring figure in film and fiction. One of the most popular questions surrounding Megalodon is whether it could still exist today, lurking in the unexplored depths of the ocean. While scientists largely dismiss this idea, unexplained sightings and sonar anomalies continue to spark speculation. We explore the theories and myths about Megalodon's possible survival, featuring deep-sea exploration footage and expert opinions. Marine scientists say, while it's highly unlikely that a predator of Megalodon size could survive undetected in today's oceans, the idea persists in the popular imagination. The truth, however, is that the deep ocean still holds many mysteries. The Megalodon may be gone, but its legend lives on. From its dominance in the prehistoric seas to its place in our imaginations today, this mighty shark reminds us of the power and mystery that lies beneath the waves. The ocean still holds many secrets, some waiting to be discovered, others lost to time. Sharks have a 450 million year evolutionary history, making them one of the oldest and most successful predators on Earth. They first appeared in the Devonian period, developing streamlined bodies and primitive jaws. During the Carboniferous period, sharks diversified, becoming dominant marine predators. In the Mesozoic era, alongside dinosaurs, sharks like Hybidus evolved larger, serrated teeth and stronger jaws to hunt massive prey. Despite mass extinctions, including the one that wiped out the dinosaurs, sharks survived. Species like the colossal Megalodon thrived before going extinct. Today, over 500 species of sharks, including the great white and hammerhead, roam the oceans, specialized for different environments. Their sensory abilities, such as electroreception and an acute sense of smell, make them apex predators. However, modern sharks face threats from overfishing and climate change, endangering their future survival. Despite these challenges, sharks' long history of adaptation shows their incredible resilience in the face of environmental changes. Long before the formidable Megalodon emerged as the apex predator of the oceans, an array of lesser-known ancient sharks reigned supreme in the prehistoric waters. These early predators were not only diverse in species, but also remarkably adapted to their environments, showcasing an array of forms and hunting strategies that fascinate paleontologists to this day. Take, for example, the Helicoprion, known for its unique spiral tooth whorl that resembled a circular saw blade. This bizarre adaptation allowed it to slice through prey with astonishing efficiency, targeting soft-bodied cephalopods that thrived in the ancient seas. Imagining the school of Helicoprion gliding through the water, its mouth agape, reveals the advanced predatory techniques that these sharks employed in their hunt. The age of the Cretaceous also brought forth the mighty Cretoxorina, often referred to as the Ginsu shark. With its elongated body and razor-sharp teeth, it was a highly effective hunter capable of taking down large marine prey, including other sharks. Visualize the adrenaline-pumping scene of a Cretoxorina pursuing its next meal, weaving through the vibrant coral reefs and employing its speed to outmaneuver unsuspecting fish. Then there was the formidable Megalodon's cousin, Ototus megalodon, a giant shark that flourished in the Tethys Ocean. This shark bore impressive rows of robust teeth designed for crushing and slicing flesh. Its sheer size and strength made it one of the most fearsome predators of its time, dominating at the top of the food chain. Think of Otodus gliding effortlessly through the depths, a shadow that instilled fear in all who crossed its path. Moreover, the unique adaptations of these ancient sharks reveal the environmental pressures they faced. From the wide jaws of the Hybodus, able to capture prey from various angles, to the slender form of the Striatolamia, built for swift and agile hunting, each shark illustrates a piece of the evolutionary puzzle leading to the modern species we know today. Their remarkable resilience in adapting to changing oceanic conditions highlights the dynamic ecosystem of prehistoric waters. In conclusion, the world of ancient sharks, before Megalodon, is a fascinating chapter in the history of marine life. These lesser-known giants not only tell the story of primal predation, but also draw connections to our current understanding of sharks' evolution and their crucial role in the marine ecosystem, underscoring the importance of preserving their modern descendants today. Imagine diving into ancient oceans, where a unique predator lurked beneath the waves, the Helicoprion, a creature that seamlessly melded ferocity with mystery. This prehistoric shark, which roamed the seas around 290 million years ago, possesses a jaw unlike any known marine animal. Its most striking feature is the spiral arrangement of teeth resembling the teeth of a buzzsaw, which has intrigued paleontologists and ocean enthusiasts alike. Fossils depict Helicoprion with a mouth that appears surreal, packed with numerous thick, sharp teeth arranged in a whorl. These teeth were not just for show, they were powerful tools, ideal for slicing through flesh and tearing apart schools of fish. The spiral configuration enabled Helicoprion to grip and shear its prey effectively, a hunting strategy emblematic of both elegance and brutality in the prehistoric predator's approach to feeding. What makes Helicoprion even more captivating is its resemblance to modern sharks, yet it belonged to an entirely different order, known as the Synnarhinchidae. The anomaly of trying to fit this creature within the tree of evolution presents challenges and sparks discussions among scientists. By analyzing its jaw structure and other remains, experts have proposed various lifestyles for the Helicoprion, pondering whether it hunted near the ocean floor or swam to greater depths for its meals. Understanding the habitat of Helicoprion sheds light on the environments it thrived in. Living during the late Paleozoic era, this creature swam in the warm, shallow waters of ancient oceans, where it encountered a diverse array of marine life. Fossil records suggest that Helicoprion coexisted with other unique creatures of its time, creating an ecosystem full of competition and adaptation, leading to the evolution of fascinating hunting strategies. The enigma surrounding Helicoprion's extinction also adds to its allure. This incredible predator vanished about 250 million years ago, coinciding with massive extinction events. The reasons behind this disappearance remain speculative. However, theories ranging from shifts in ocean temperatures to significant changes in marine habitats indicate how fragile evolutionary paths can be. Ultimately, Helicoprion serves as a reminder of nature's unfathomable power and the intricate web of life that once thrived in the depths of the oceans. Today, Helicoprion continues to be a focus of research and fascination. Its architectural marvel of a jaw provides insights into the evolutionary adaptations of early sharks, blurring the lines of what we know and possibly reshaping our understanding of marine biology. By studying its incredible design, we unravel a bit more about the complex tapestry of life in our planet's ancient waters. In the vast oceans of prehistory, the Megalodon ruled as the largest predator ever to have lived. This colossal shark, measuring up to 60 feet long, dominated the seas with its massive jaws and serrated teeth, designed for tearing flesh. Picture this ancient behemoth gliding through warm coastal waters, hunting giant whales and other marine creatures, establishing its reign as the ultimate ocean predator. However, as time progressed, significant environmental changes began to reshape the world's oceans. The climate shifted, leading to cooler temperatures that altered marine habitats and food sources. Megalodon thrived in warm waters, And as these areas became less hospitable due to fluctuations in temperature and sea level, its hunting grounds began to dwindle. Imagine the once vibrant ecosystem transforming into a battleground for survival, with megalodons struggling to navigate this new ocean landscape. Moreover, the rise of other marine predators contributed to the megalodon's decline. The emergence of smaller, faster sharks and cetaceans adapted to the changing environment became formidable competitors. These agile hunters could take advantage of the shifting marine ecosystems more effectively than the massive megalodon. Visualize the once mighty shark, increasingly challenged by a world of swift and cunning foes, forced to compete for dwindling resources. To exacerbate its plight, the megalodon's reproductive strategy limited its ability to adapt to these changes. Being a large, viviparous species, it produced few young, which meant it could not replenish its population quickly in the face of rapid environmental shifts. Envision the once dominant shark, now a reluctant survivor amid rising competition and dwindling numbers. Despite its fearsome reputation, the megalodon ultimately succumbed to the dual pressures of environmental transformation and competition. As the world entered the Pleistocene epoch, approximately 3.6 million years ago, the last of these magnificent sharks disappeared from the fossil record. Reflect on the legacy of Megalodon. While its reign has ended, it serves as a powerful reminder of nature's unpredictability and the delicate balance within marine ecosystems. The rise and fall of the megalodon highlights the potential impacts of climate change on even the most formidable of creatures. As we face our environmental challenges today, the story of the megalodon urges us to learn and adapt, ensuring that we do not repeat the mistakes of the past with our oceanic treasures. In the depths of the ancient oceans, an epic saga unfolded, where colossal prehistoric sharks and fearsome sea monsters engaged in a relentless struggle for dominance. Picture the waters teeming with life, illuminated by beams of sunlight streaming down, where shadows lurked waiting to strike. The mighty sharks gliding through the deep blue were the apex predators of their time, equipped with rows of razor-sharp teeth and exceptional hunting instincts. Their streamlined bodies surged gracefully through the water, embodying both power and precision. Each flick of their powerful tails sent ripples through the ocean, signaling their presence to all creatures near. But they were not alone in these vast waters. Enter the mosasaurs, titanic reptiles that commanded respect and fear. With their long, serpentine bodies and fierce jaws, mosasaurs patrolled the depths, hunting fish and even the sharks themselves. Imagine a mosasaur, its sleek form cutting through the water as it ambushes unsuspecting prey. In this relentless environment, the thrill of survival was paramount, and these two titans sometimes clashed in mesmerizing displays of strength and strategy. Epic battles erupted, with prehistoric sharks darting and weaving like torpedoes, trying to outmaneuver their monstrous foes that could easily overpower them with brute force. As the sun dipped below the horizon, hues of orange and purple enveloped the ocean, adding drama to the fierce encounters. Meanwhile, the armored plesiosaurs, with their long necks and fierce demeanor, joined the conflict. Their unique body structure allowed them to strike from unexpected angles, posing a different threat altogether. Envision the clash of teeth against hard scales, each predator testing its limits as the symphony of their struggle echoed through the depths. These battles were not just about survival, but also about asserting dominance. They resonated through the ages, telling tales of bravery and instinct. In this prehistoric world, every encounter led to a shift in the balance of power, and each survivor became a legend in the intertwining histories of sharks and the sea monsters of their time. The ocean was not just a backdrop, but a character in this battle, a chaotic yet beautiful arena where life hung in the balance. The fate of sharks and sea monsters forever entwined in a dance of life and death, a reminder of the remarkable evolutionary history that formed the legacy of our oceans today. A legacy filled with stories of ancestral fighters and the epic narratives that continue to fill aquatic imaginations, inspiring awe for the ancient beings that once ruled the waters. Fossilized shark teeth serve as time capsules, offering a glimpse into ancient oceans that roamed the Earth millions of years ago. These remnants, often weathered and worn, hold clues to the understanding of prehistoric marine ecosystems. With each tooth unearthed, scientists piece together the narrative of a world dominated by giants where massive sharks ruled the waters. The diversity of shark teeth found in sediments reveals the varying species that once prowled the depths. Different shapes and sizes indicate the diet and behavior of these ancient creatures. For instance, sharp serrated teeth belong to predatory sharks that feasted on fish, while flatter, broader teeth belong to bottom feeders that scavenged on the ocean floor. By analyzing these teeth, paleobiologists can reconstruct predator-prey dynamics and infer the ecological roles that these sharks played in their environments. These teeth also provide insight into the evolutionary changes that have occurred over millions of years. As shark species adapted to their surroundings, their teeth underwent modifications, responding to the availability of prey and environmental shifts. The discovery of certain tooth types in specific strata can indicate periods of climate change or shifts in ocean currents, marking significant events in Earth's geological history. This evolutionary narrative allows us to trace how sharks have survived through mass extinctions, adapting to the planet's ever-changing climates and ecosystems. Moreover, fossilized shark teeth are crucial for understanding ancient ocean temperatures and habitats. The chemical composition of these teeth reflects the temperature of the water in which the sharks swam, providing valuable data about prehistoric climates. By comparing these findings with geological data, researchers can reconstruct how ancient sharks interacted with their ecosystems, revealing a complex web of life that existed long before humans. In essence, fossilized shark teeth do more than just represent the remnants of formidable predators. They are keys that unlock the doors to a mysterious past, illuminating the interconnectedness of life forms and the environments they inhabited. Each shard of enamel tells a story of survival, adaptation, and the ebb and flow of ancient oceans, guiding scientists as they unravel the secrets of Earth's rich aquatic history. Thus, the study of these teeth not only enhances our understanding of prehistoric sharks, but also deepens our appreciation for the intricate tapestry of life in our oceans. Megalodon, the colossal shark that roamed the oceans millions of years ago, captivates the imagination of many. However, alongside its incredible size and predatory prowess come myths that embellish its legacy. One of the most persistent myths is the belief that Megalodon might still exist in the depths of our oceans. While it's thrilling to entertain the idea of this ancient predator lurking beneath the waves, scientific evidence overwhelmingly supports its extinction over 2 million years ago, concluding that the ocean's vastness contains no hidden megalodon populations. Within this mythological framework is the exaggeration of its size and power. Megalodon is often depicted in films and media as an unreasonably gigantic creature, with estimates reaching lengths of 60 feet or more. In reality, though it was indeed massive, evidence suggests that Megalodon typically ranged between 40 to 50 feet in length. Such vast differences highlight how sensationalism can overshadow factual data, leading audiences to a skewed perception of this famous shark. Megalodon's diet also prompts a flurry of myths. Some claim that it primarily targeted whales, portraying it as an unrivaled apex predator. While it did hunt large marine mammals, the fossil record indicates a more diverse diet that likely included fish and other marine creatures. This illustrates the adaptability of Megalodon as a hunter, rather than the singular focus often depicted in sensational narratives. Another fascinating myth revolves around the death throes of Megalodon. Theories abound regarding its decline, with some attributing it to competition with other shark species or drastic environmental changes during the Pleistocene epoch. In truth, scientists propose that a combination of factors led to its extinction, including a changing climate and the decline of its primary food sources. Such complexity adds depth to the Megalodon's story, rather than reducing it to simplistic tales of survival. To truly appreciate Megalodon, one must sift through the myths and focus on the facts. The real Megalodon was a remarkable part of Earth's prehistoric tapestry, a creature that played a significant role in the evolution of marine ecosystems. While it may inspire tales of monstrous feats and hidden depths, the truth reveals a more nuanced narrative of survival and extinction, leaving us with a sense of wonder about the ancient seas and their inhabitants. The Devonian period, often referred to as the Age of Fishes, marked a revolutionary epoch in the history of life on Earth. This period, which spanned from approximately 419 to 359 million years ago, witnesses an explosion of marine diversity, setting the stage for the evolution of various fish species, including the earliest sharks. The warm, shallow seas teemed with life, where complex ecosystems flourished, giving rise to the evolution of new feeding strategies and hunting techniques. Amidst this vibrant marine tapestry, sharks began to emerge as formidable predators. The primitive sharks of the Devonian period were quite different from their modern counterparts. Featuring cartilaginous skeletons and a variety of unique adaptations, these sharks were well suited to their environments. They possessed sharp, serrated teeth, capable of slicing through flesh, allowing them to effectively hunt other fish. Fossil evidence from this period illustrates a wide range of shark forms, from the ancient Cladocelalx to the more advanced Hybodus, each contributing to the evolutionary lineage of sharks. The developmental phases of sharks during the Devonian also reflected competing environmental pressures. As fish diversified, the competition for resources intensified. This era saw the emergence of new prey species, prompting sharks to adapt and refine their hunting abilities. The anatomical features present in early sharks, such as enhanced sensory systems and streamlined bodies, facilitated their role as apex predators within marine ecosystems. Their adaptability and predatory prowess were instrumental in shaping the evolutionary trajectory of these remarkable creatures. The legacy of the Devonian sharks is etched deeply into the history of marine life. As the planet transitioned through subsequent geological periods, these early sharks laid the groundwork for the modern species we know today. The evolutionary advancements born during the Devonian paved the way for survival and adaptation, enabling sharks to withstand millennia of environmental changes. Thus, while the Devonian period may have been characterized by a burst of fish diversity, it was undoubtedly sharks that emerged as the enduring symbols of ocean predation. Today, the story of Devonian sharks is not merely a glimpse into the past, it is a testament to resilience and evolution. As we continue to explore the mysteries of these ancient seas, the remarkable journey from primitive swimmers to apex predators highlights the dynamic nature of life on Earth and the foundational role that the Age of Fishes played in shaping the future of marine biodiversity. The tale of survival etched in the annals of time belongs to the prehistoric sharks. While the mass extinction event approximately 66 million years ago saw the demise of the colossal dinosaurs, these ancient predators thrived, navigating the turbulent waters of change. Emerging from the shadows of cataclysm, sharks evolved and adapted in ways that ensured their place in the new world, representing resilience in the face of adversity. The environmental upheaval triggered by the infamous asteroid impact generated widespread ecological chaos, resulting in the extinction of many terrestrial species. Yet sharks, with their myriad adaptations, weathered the storm of transformation. One primary factor contributing to their survival was their evolutionary design. Sharks possess a unique anatomy. Their cartilaginous skeletons made them lighter and more agile compared to bony fish. This streamlined structure facilitated swift movements necessary for hunting diverse prey in ever-changing aquatic ecosystems. Additionally, their keen senses, including acute smell and the ability to detect electric fields, positioned them as apex predators in the marine food chain. These remarkable features allowed sharks to exploit the available food sources, which included smaller fish and invertebrates, essential in a post-dinosaur world that required resourcefulness. In the aftermath of the mass extinction, the oceans witnessed a significant shift. With the disappearance of larger marine reptiles and competition from other predators diminished, sharks seized the opportunity to diversify and occupy new niches within their environment. Over time, various species emerged, each adapted to survive in different habitats. From the shallow coastal waters to the deep abyss, sharks flourished, evolving distinctly in response to changing climates and prey availability. The great white hammerhead and tiger shark are just a few examples of the diverse adaptations that arose from their ancestors' resilience. The story of sharks after the dinosaurs is not merely one of survival, but of remarkable adaptability. They capitalized on a world in flux, embodying an evolutionary success story that has persisted for millions of years. Today, modern sharks continue to rove the oceans, showcasing their evolutionary prowess. Their existence is a testament to the triumph of life through relentless adaptation, proving that even in the most catastrophic events, nature finds a way to endure and thrive. Imagine plunging into the depths of history, where gigantic creatures ruled the oceans long before the age of dinosaurs. The quest to uncover the largest prehistoric sharks begins with ancient marine landscapes, where these formidable predators thrived. As paleontologists sift through layers of sediment, they unveil massive teeth and enormous vertebrae that hint at the extraordinary scale of these creatures. Every discovery serves as a reminder of their dominance in the aquatic food chain, sparking intrigue about their physical characteristics and behavior. Advancements in technology have propelled our understanding of these ancient giants. With the use of CT scans and 3D modeling, researchers can reconstruct the anatomy of extinct shark species like Megalodon and Helicoprion, shedding light on their size, shape, and ecological roles. These models illustrate how the Megalodon could have reached lengths of over 60 feet, possessing jaws strong enough to crush bone with ease. The mere concept of such immense creatures teeming in prehistoric oceans sparks fascination and fear, leading to endless hypotheses about their hunting strategies and interactions with other marine life. As excavations continue in various global sites, paleontologists are beginning to piece together the evolutionary journey of these colossal sharks. Fossils found in Europe, North America, and Australia reveal a time when these fish dominated both the open ocean and coastal waters. Each find tells a story that intertwines with the prehistoric ecosystem, including the species that preyed upon them and those that shared their habitat. As researchers draw connections between fossilized remains and modern sharks, they enhance our comprehension of how these ancient giants influenced today's marine biodiversity. With each dig, the shadows of these magnificent creatures linger, reminding us of a world when they ruled the seas, leaving an indelible mark on the history of marine life. Their legacy persists in our oceans today, as scientists unearth clues of the ecological balance that once allowed their kind to flourish. Discovering the stories etched into fossil records allows us to appreciate the sheer vastness of life on Earth and inspires a modern generation to protect the ocean's existing sharks and their fragile habitats. In the grand tapestry of life, the tales of fossilized giants remind us of our responsibility to safeguard the creatures still swimming through our oceans, echoing the past in vibrant harmony.